In this lesson, we're going to examine relationships between lines, in particular between their slopes. So the first idea we're going to talk about is about a parallel line. Parallel lines never cross since they have the same slopes. So we're looking at these two lines, and we'll call the bottom one here y1. Its slope from here up and over is they go up to and over 3. And this one, y number 2, again, if you find some nice points, a little tricky on here, you go up to and over 3. So they have the same slopes. Obviously, they have different y-intercepts. This one is, I don't know, somewhere negative 1.5. This one is, I don't know, maybe positive 1.2. So they have similar lines, similar equations in that the slopes are the same, but their y-intercepts are very different. Okay, so we have a relationship there. Perpendicular lines sort of the complete opposite. When perpendicular lines cross, they form a 90-degree angle. And what that means is their slopes are negative reciprocals. So if I look at two lines and examine their slopes, and I've been told they're perpendicular, that means the slopes have to have opposite signs and the rise and run have been flipped. So for example, in the blue one here, we have to go down 2 and over 3, but the red one, between two nice points, here, go up 3 and over 2. So as you can see, these two slopes are negative reciprocals. They have the opposite sign. This one's positive, this one's negative, and my rise and my run have been flipped. So if I've been told something's perpendicular, I can very quickly find a slope for just flipping it over and changing the sign. Now, just one thing to point out about the negative sign. It doesn't matter where you put the negative sign, right? We know negative 2/3 is the same as 2 over negative 3, which is the same as negative 2/3. Just the fact that it has a negative sign makes it negative. So when you flip it over, the sign can go on whichever part you want, the top, the bottom, or in front. So let's take a look at these equations. I want to know if these lines are parallel, perpendicular, or neither. So this is all about slope. Okay, that's all I care about here, slope. So if things are in the form mx plus b, which they are, my slope is very easy to find. For here, m is 3. For this one, m is 1. Well, they aren't parallel because they're not the same. Are they perpendicular? Well, if they were, I'd have to be able to flip this over. That would become 1/3, and it would have to be negative. That's definitely not this one. So this is neither. Okay, these are not opposites. They're not the same. There's no relation. Look at the next one. My slope is 1/4. My slope is -4. So put those down. If you want, you can think of -4 as being -4 over 1. What do I notice? I notice that these two things have the opposite sign, and they're flipped over from one another. So that makes these things perpendicular. We often use the upside down T symbol for perpendicular, okay? Sort of a shortcut. Okay, take a look at the last one. My slope for this one is 2. And the next one, well, that one's kind of hard to figure out because it's not in the right order. It's not in mx plus b. So we need to rearrange. So let's rearrange this one. There's two ways we'll talk about both. Method number 1, I'll leave the y where it is and bring everything else to the other side. Be careful that the y is a -3 still though. Then to get y by itself, I have to divide everything by -3. And y becomes 2x plus 6. That's method 1. Method 2, same question, okay. As I bring the y to the other side, it becomes a 3y, and divide everything by a positive 3. So it's kind of your choice which way you want to do this. I don't care which way, it doesn't make a difference. It's the same answer either way. Either way, I get a slope of 2. And remember, our objective here was comparing that slope to this slope. And I notice they're both 2's, so these are parallel. And the key here in part T is the right order. Our objective is to identify our slope, so put it in a form where you can find the slope very quickly. Okay, why do I like this relationship idea? That allows me to find equations of lines. So, going back to what we've been doing the last 2 days, we were looking at equations of lines. We always want the order mx plus b. Well, now, I might be able to find my slope instead of using the slope equation, or instead of being given the slope, my slope might be related to something else. For example, in the first one here, I want to find an equation line with the same slope as this and the same y-intercept as this. Well, if it has the same slope, here's my slope, so my m has to be negative 1/3. If it wants to be the same y-intercept as the other one, my y-intercept of this one is negative 8. Well, those are the 2 pieces of information I need for a line, right? So, my equation, which is a brand new equation, is negative 1/3 x minus 8. Okay, let's go to the second one. I want to find the equation of a line that's parallel to this and goes through this point. Well, if it's parallel, it has to have the same slope. So we have to figure out what our slope is. That the form that I'm given is not a great one, so let's fix that. Let's take this and rearrange it. Bring the 2 to that side, bring the 1 to that side. Divide it all by 3. So I got negative 2/3 x minus 1/3. Why did I want this? We're trying to figure out it's parallel to it. So from here, what is our slope? Our slope is that piece. So parallel means we have negative 2/3. We're also told to go through a point. So using those 2 pieces of information, we can figure out our line. Y equals negative 2/3 x plus b. Fill in what we know. Our point is 1, 2. So 2 over here, 1 over here. Solve for b. That's what we did yesterday, right? Just some messy ones. Expand your brackets. Rearrange. Add them together. Use your fraction button here, common denominator. And we get an equation, y equals negative 2/3 x plus 8/3. And it all came about because we were told it had to be parallel to this line. That's our first thing we have to find, our slope. Okay, got more. I want a line to be perpendicular to this one, but the same y-intercept as this one. Okay, so what does perpendicular mean? Perpendicular means the opposite slope. So if I identify my slope here as 2, it's, or 2 over 1 if you want to think of it, it's opposite slope. So I say perpendicular slope. I have to flip it over and change the sign. If I want to find the y-intercept, I got to put in a good form to find the y-intercept. In other words, mx plus b. So I'm going to bring the 6 over and put the 2y on that side. Now I don't have to. I could have brought the 3 over. That would work just fine too. I'm going to divide everything by 2 this time. I got 3 halves x minus 3 equals y. What did I want from there? I want the y-intercept. Y-intercept is right here. So b is negative 3. So let's take our 2 pieces of information, that one and that one, and we get ourselves a new line, negative 1/2 x minus 3. And one more. I want a line that's going to be perpendicular to x equals 5, and the same y-intercept as y equals 3. Okay, oh, that's nice. There's my B. The tricky part is this. Perpendicular x equals 5. Let's think about that line for a second. What is x equals 5? This is a weird line. It's a vertical line through 5. So we know this line's going to go like this, right? Straight up and down. Oops. Okay, let's fix that. Through 5. So it's something perpendicular to that. Well, perpendicular to that would be a horizontal line. Specifically, a horizontal line that goes through -3. So if I think of that as -3, what's the equation of this line? The equation of this line is y equals -3. So this is almost like a trick question. They actually gave us the equation right here. The blue line is the only one that's perpendicular to x equals 5 and passing through that point. And that's kind of a tricky one. Okay. Okay, last little part. Let's compare lines. So I have two different lines. I want to compare them by looking at their slopes. I want to be able to justify my answer. I want to include information about steepness, direction, and whether they're parallel or perpendicular. So first thing I want to do is, are these in a good form to compare slopes? Line number 1, definitely. mx plus b, perfect. Line number 2, not so much. So let's fix it. Y equals, bring the 3 to the other side and the 12 to the other side. Okay, so steepness, slopes. Slope 1, 3. Slope 2, -3. Which of these is steeper? Well, the fact that they both have the number 3 tells me these have the same steepness. They're both 3. One of them, line 1, goes up to the right. It's a positive slope. Line 2 goes down to the right. It's a negative slope. Okay, so I was thinking about this. I'd have one that goes like this, 3, and I have one that goes exactly the same, down 3. They have the exact same steepness, they just go different directions. And these lines, I'm looking at parallel, perpendicular, neither now, are, well, they're not parallel because they're different numbers. One's positive, one's negative. They're not quite perpendicular, they're not flipped, though they have opposite signs. So we'd say these are neither parallel or perpendicular, since they are not equal, nor, and here's our fancy words, negative reciprocals. Okay, and that's how we deal with parallel and perpendicular lines. So just to point out, make sure they're in the right order first. That's kind of the key. Mx plus b is what you need to be able to deal with these lines. We're trying to look for relationships between lines now. So think with the information you're given, what can you use that for, and find your new equations. There's a couple of questions for homework you can try.